Question number 10. So how you would connect two 4 omega resistor to produce a combined resistance of 2 ohm and 8 ohm. First case, they're given two resistances, that is 4 omega, another resistance also 4 omega. Question is that how we connect these two resistances so that their equivalent resistance is equals to 2 omega. As we can see here, equivalent resistance is smaller than their individual resistances. Hence, the combination of these resistances is in parallel. So, let us prove this. Two resistances, 4 omega, another also 4 omega, R1 and R2 are connected in parallel. Then their equivalent resistance is equals to their reciprocal sum, that is 1 by 4 plus 1 by 4. Then we get 1 plus 1, that is 2 by 4. On cancel it by 2, we get 1 by 2. Taking reciprocal, then we get 2 omega equivalent resistance. So here in first part, equivalent resistance must be 2 omega. So the connection of 4 omega resistances to 4 omega resistances is in parallel as it is shown. Part B of question number 10. Here two resistances 4 ohm each are connected so that their equivalent resistance is equals to 8 omega. Resistance 1 4 omega. Resistance second also 4 omega. How these two resistances are connected so that their equivalent resistance is equals to 8 omega. As here equivalent resistance is greater than their individual value. So the connection of these two resistances is in series, because in series combination resistance of overall circuit is increases. So here both these resistances of 4 omega each are connected in series. Let us prove this. Equivalent resistance of series combination is equals to sum of their values, that is 4 plus 4, we get 8 omega overall resistance. In first case, overall resistance decreases, so the connection is in parallel. In second case, overall resistance increases, so the connection is in series. Question number 11. Which of the following resistor arrangement A or B has the lower combined resistance? In A, resistance is given 10 omega. Okay. B, resistance R1 is 10 omega and resistance R2 is 1000 omega. And both these resistances are connected in parallel. So in part B, we have to find the equivalent resistance of this parallel combination, that is 1 by R1 plus 1 by R2. Putting their value 1 by 10 plus 1 by 1000, we get LCM of 1000. Then it is equals to 100 plus 1, that is 101 by 1000, 1 by R equivalent. On taking reciprocal of this, we get 1000 divided by 101. Then the equivalent value of this combination is 9.9 omega. So here question is that A or B, which arrangement has lower combined resistance? A combination has 10 omega resistance, whereas in B combination has two resistances which are in parallel, which we solve to find their equivalent resistance, that is 9.9 omega. So here arrangement B has lower electrical resistance. We are going to discuss question number 12. Calculate combined resistance. In given figure, R1 is 500 omega and R2 is 1 kilo omega. Here R1 and R2 resistances are connected in series, then their equivalent resistance is equal to their values sum, that is 500 omega plus 1 kilo omega. First, convert 1 kilo omega into 1000 omega. We get 1500 omega. It is the equivalent resistance of both these resistances which are connected in series. Two resistances are given, R1 and R2. R1 has 500 omega resistance, R2 1 kilo omega. First convert 1 kilo omega into 1000 omega and then add 1500 overall equivalent resistance of the given circuit. We are going to discuss question number 13. Calculate combined resistance given two resistances 2 omega and second also 2 omega, R1 and R2. As here R1 and R2 are connected in parallel. Here R1 and R2 are connected in parallel, so their equivalent resistance is equal to the reciprocal sum of their respective values, that is 1 upon 2 plus 1 upon 2. On taking the LCM of 2, we get 1 plus 1, that is 2 by 2, and overall equivalent resistance is 1 omega. Here two resistances are given, R1 and R2, each have 2 omega resistances. Both of these resistance connected in parallel. Then we have to find the combined or equivalent resistance. And we know that in parallel combination, equivalent resistance is equal to the reciprocal sum of these resistances. Then we take the reciprocal and LCM of 2 and we get the value final 1 omega. Let us discuss question number 14. Calculate combined resistance. Here R1 has 4 omega resistance, R2 also 4 omega, and R3 is 3 omega. Here these three resistances are given, but R1 and R2 are connected in parallel. So first we find the equivalent value of these parallel resistances. Then R1 and R2 are connected in parallel combination. Then their equivalent resistance, let R dash is equal to 1 by R1 plus 1 by R2. Putting their values 1 by 4 plus 1 by 4, we get LCM of 4 and 1 plus 1 equal 2 by 4. Cancel it by 2, we get 1 by 2. Then on taking reciprocal of 1 by R dash and 1 by 2, we get their equivalent resistance equal to 2 omega. Now we find the equivalent value of these two resistances which are connected in parallel. So we draw their NIF circuit diagram where we have overall equivalent resistance of 2 omega, R dash and R3. It is R dash, it is R3. R dash is equals to 2 omega and R3 has a value of 3 omega. It is. Here R dash and R3, R dash and R3 are connected in series. Then their equivalent resistance are double dash. Let their equivalent resistances are double dash is equal to their value sum, that is 2 plus 3 equals to 5 omega. It is the overall equivalent resistance of the given circuit, that is R double dash. As in given circuit circuit diagram, R1 is 4 omega and R2 4 omega. Both these are connected in parallel. So first we find the equivalent resistance of this parallel combination, that is R dash. We value of it 2 omega. Then equivalent resistance of these two resistances and R3 are connected in series as shown in this circuit. Then we get the overall equivalent resistance of this circuit is R double dash, and we only sum this R dash and R3, and we get the final equivalent resistance is 5 omega. Next we are going to discuss question number 15. Find current each resistor in the circuit shown below. As circuit is shown here battery is connected of 24 volt. R1 resistance 4 omega, R2 resistance of 6 omega. First we draw the direction of the current in this circuit diagram. As we know, it is the positive terminal and it is the negative terminal of the cell. The conventional direction of electric current is from positive terminal of a cell or battery to the negative terminal. That is, current यहाँ से start होगा. We can see here two paths. Then here let current is I1 across R1 and current is I2 across R2 resistance. Here we get to know that R1 and R2 are connected in parallel, as current is divided into two branches, that is I1 and I2. So current in resistance R1 is equals to I1, and I1 equal, by Ohm's law, V equal Ri and I equal V by R. So I1 is equals to V by R1. Value of V is equals to 24 volt. R1 value is 4 omega. By simplifying 24 by 4, we get 6 ampere of current in R1 resistor. We have to find the value for I2, that is V by R2. V is 24 and R2 is 6 omega. Cancel it, we get 4 ampere of current in I2. Here circuit diagram is given. Potential of the cell is given 24 volt. We first draw the direction of the current in this diagram. Direction of current is from positive terminal of the cell to the negative terminal. Then further current divided into two branches, that is I1 and I2. So we come to know that R1 and R2 are connected in parallel. That's why the current across R1 I1 and current across R2 resistance is I2, and we have to find these values, that is I1 and I2. We get the formula I1 equal V by R1, putting the value for cancel it by, and then we get 6 ampere current. Here value for V is 24, value for R2 is 6 omega. Cancel it by 6, we get 4 ampere of current. We are going to discuss question number 16. A battery of 9 volt is connected in series. 9 volt battery connected in series with resistor of 0.2 omega, 0.3 omega, 0.4 omega, 0.65 omega and 12 omega. How much current would flow through the 12 omega resistor? We have given 5 resistances. Each value are different, which are connected in series. With that 9 volt battery, we have to find the value of current across 12 omega resistor. So first we draw the circuit diagram for this problem. Let R1 resistance, R2 resistance, R3, R4 and final R5 resistance. Connect it to the source of power supply, that is cell or battery, positive and negative terminals. Connect to the closed switch and then complete the circuit. Here it is 9 volt battery, R1, R2, R3, R4 and R5. 5 resistances connected in series. Their value 0.2 omega, 0.3 omega, 0.4 omega, 0.5 omega and finally is 12 omega. Direction of current is from positive terminal to the negative terminal. Then we have to find the value for 12 ohms, that is I, because in each resistances current I is flowing because all the 5 resistances are connected in series. Here we have to find the current across R5, that is 12 ohm resistor. But the current is same in the whole circuit because it is in series. So we have to find the value for I. First of all, we have to find equivalent value of all these resistances. For series, we know that 5. Sum of all these resistances 0.2, 0.3, 0.4, 0.5 and 12. Then we finally get the value 13.4 omega. So here equivalent resistance is 13.4 omega. Now applying Ohm's law to find the value of I. As we know, V equal Ri and I equal V by R, and R is equivalent resistance. Value for V is 9. Value for equivalent resistance is 13.4. On displacing the decimal, we get 90 by 134. On cancel it by 2, we get 45 by 67, which is equals to 0.67 ampere current. R1, R2, R3, R4 and R5. 5 resistances are given which are connected in series. So we draw the circuit diagram. Finally, we have to find the value for current across 12 ohms resistor. As we know, in series circuit, the current flowing is same. So we have to find the value for I. First of all, we have to find the value of equivalent resistance. And for series combination, equivalent resistance is equals to the sum of all the resistances, which is equals to 13.4 omega. Now we apply the Ohm's law and calculate the value for I, which is we find 0.67 ampere. Now we are going to discuss question number 17. An electric bulb of resistance 20 omega and resistance wire of 4 omega are connected in series with a 6 volt battery. Draw the circuit diagram and calculate. First we have to draw the circuit diagram for given problem. A bulb, it is a symbol for electric bulb, and a resistance wire. Resistance wire is 4 omega and it is 20 omega resistance of this bulb. Let it is R1 and it is R2. Both are these connected in series as it is shown. Then connect it to the source of power supply, that is shallow battery, positive and negative terminals. Close switch and close the circuit. Now direction of current is from positive terminal of a shallow battery to the negative terminal. We have to find first total resistance. So first part, as we know, R1 and R2, that is bulb and resistance wire, are connected in series. So their equivalent resistance is equal to the sum of their respective values, that is 20 plus 4, which is equals to 24 omega. So it is the answer for A. Now in part B, we have to find the value for current. As we know, voltage of the battery is 6 volt. Voltage of this battery is 6 volt. So by Ohm's law, I equal V by R equivalent, and I equal 6 by 24. On cancel it by 6, then we get 1 by 4, that is I equal 0.25 ampere. So it is the current in this given circuit. Now we have to find the potential difference across electric bulb. As we know, in series circuit, potential difference is differ both in R1 and R2. Let it is V1 across R1 and potential across R2 is V2. In series circuit, potential is differ, so we take V1 across R1 across bulb and V2 across R2, that is resistance wire. In part C, we have to find the potential difference across electric bulb, that is V1. And we know that by Ohm's law, V equal IR. Overall value of current is, we know, 0.25 multiply R1. In the value for I, that is 0.25 multiply 20, that is R1, we get 5 volt potential across electric bulb. Now we have to find V2 in part D, that is potential difference across resistance wire. Resistance wire का potential difference is V2. So here 0.25 multiply 4, then we get 1.00 volt potential difference across resistance wire. Electric bulb of 20 ohms resistance and a resistance wire of 4 ohms are given. Both of these are connected in series as shown in this circuit diagram. Now we first find the total resistance of the circuit. As we know, in series both the resistances sum equals to their equivalent value, that is 20 plus 4 equals to 24 omega is the total resistance of the given circuit. In part B, we have to find the current. By Ohm's law, I equal V by R equivalent. Putting the value, cancel it by 6, we get 1 by 4, and on calculating, that is 0.25 ampere of current. Finally, C point, we have to find the potential difference across electric bulb. So in series, potential drops takes place, that is we let V1 potential across R1, that is electric bulb, and V2 potential across R2, that is resistance wire. So here V1 equal IR1. Putting the value for I and R1, on multiplying we get 5 volt potential across electric bulb. Similarly, we have to find the potential difference across resistance wire, that is V2, and V2 equal IR2. Putting the value for I 0.25 and R2 4. On multiplying we get 1 volt, that is V2 value. Let us discuss question number 18. 3 resistors are connected as shown in the diagram. Here R1 is of 5 omega, R2 10 omega and R3 15 omega resistances. Through the resistor 5 ohm a current of 1 ampere is flowing. That is 1 ampere current is flowing through 5 ohm resistor. What is the current through the other two resistors? What is the potential difference across AB and across AC? What is the total resistance? So first we have to find the equivalent resistance of these two resistances which are connected in parallel. So here R2 and R3 are connected in parallel. So their equivalent resistance R equivalent is equals to 1 upon R2 plus 1 upon R3. Putting the value for R2, that is 10 plus 1 upon 15, we get equivalent resistance with LCM 30, 3 plus 2, that is 5 by 30. On cancel it by 5, we get 1 by 6. Taking the reciprocal, we get 6 omega equivalent resistance of these two resistances. Equivalent resistance of these resistances is 6 omega. First we solve the equivalent resistance of these two resistances, which we get 6 omega. Now we find the value of current through the two resistors. In this circuit, here current I is flowing in the circuit, but R2 and R3 resistances are connected in parallel. So the current divide into its branches, that is I2 current across R2 resistance and I3 current across R3 resistance. So first we have to find their value. Current across A to B is let IAB, and current across B to C is let it is IBC. As we know, IAB and IBC, both of these resistances get converted into 6 ohms resistance. That is their circuit diagram. is converted into this. It is 6 omega resistance, that is R equivalent of these resistances, and it is R1, that is 5 omega. Here current IBC is flowing from B to C, and from A to B current IAB is flowing. As we know, both R1 and R equivalent are connected in series, so their current is same. Then IAB is equals to IBC, which is equals to 1 ampere, as IAB is given to 1 ampere here. So now we find the value for V for these resistances. As we know, these resistances are connected in parallel, then their potential difference across VAB is equals to IAB multiply R1, that is 1 multiply 5 is equals to 5 volt. Similarly, potential difference across B to C, potential difference across BC is equals to IBC multiply equivalent resistance, that is IBC is equals to 1 ampere and equivalent resistance of BC is equals to 6 omega, that is over 6 volt potential. Equivalent resistance of R2 and R3 resistance is 6 omega, and we redraw the circuit diagram, that is R1 5 omega and R equivalent is 6 omega. A to B current IAB, which is equals to 1 ampere given, and current across B to C is IBC. Now we say that both of these are series, then the current is same, that is 1 ampere. Now we find the value for VAB, which is equals to IAB multiply R1, and we get 5 volt. Next we find the value for VBC, which is equals to IBC current and their equivalent resistance, that is 6. Then we get 6 volt potential. Now what is the current through the other two resistors? We have to find the value for current, that is, let current across R2 is I2 and current across R3 is I3. So we now have to find the value for I2 and I3. Potential across A to B is 5 volt and potential across B to C is 6 volt. Now potential across B to C is equals to V, that is V equal VBC is equals to 6 volt. Overall potential of these two parallel resistances R1 and R2 is equals to 6 volt. Now we have to find the value of current, that is current across two resistors, that is I1. I1 equal to V by R1. Value of V is 6, R1 is 10. Then we get 0.6 ampere of current across R2 resistor. Now we have to find the value for I2, that is V by R2. Value for V is 6 and R2 is 15. On cancel it by 3, we get 2 by 5, that is 0.4 ampere of current. So here we solve the part A, where we have to find the value for current across R1 and R2. So we get I1 0.6 ampere and I2 0.4 ampere. Now we have to solve part B, what is the potential difference across AB and AC. In part B, potential across A to B is equals to 5 volt. But the potential across A to C is equals to potential across A to B plus potential across B to C. Here we have to find the potential from A to C. It covers both potential, that is potential across A to B and potential across B to C. So we put the value for AB 5 and BC 6. We get the total potential is 11 volt. Now part C. We have to find the total resistance. As we know, R1 resistance is equals to 5 omega, and already we find their equivalent resistance, which is equals to 6 omega. So their equivalent resistance, that is R equivalent, is equals to 6 omega. Then total resistance of this circuit is equals to R1 plus R equivalent, that is 5 plus 6 equals to 11 ओमेगा. इस क्वेश्चन को हमने किस तरह से सोल्व किया है? इसमें सबसे पहले इक्विवेलेंट रेजिस्टेंस R1 R2 का फाइंड किया, विच इज इक्वल्स टू 6 ओमेगा. देन in part first we have to find the value of current across R1 R2. For this we need to know the value of potential across R1 R2. So we let it VBC or V, which we get 6 volt, Then we find the value for I1 and I2, that is 0.4 and 0.6 ampere. Next, what is the potential? In part B, we have to find the potential across VAB and AC. Potential across AB, we know 5 volt. And potential across AC cover both the potential across VAB and B to C. So we add the value, that is 5 plus 6 equal 11. Next, we have to find the total resistance. So total resistance के लिए हमने सर्किट डायग्राम को दोबारा रीड्रॉ किया. That is R1 5 omega and R equivalent for R2 and R3 is 6 omega. In series, both these resistances sum up or add up, that is we get 11 omega total resistance. Let us solve numerical number 19. For the circuit shown in the diagram below, diagram is given. What is the value of current through 6 omega resistor and potential difference across 12 omega resistor? 4 volt cell is connected in the given circuit. Direction of current is from positive terminal to the negative terminal, that is positive to negative. Here it is let R1 resistance, it is R2 resistance, it is R3 and it is R4. As R1 and R2 are connected in series, similarly R3 and R4 also connected in series. First we have to find the equivalent resistance of R1 and R2. So here and R2 are connected in series. Let their equivalent resistance is equals to R dash, which is equals to R1 plus R2. Putting their value, that is 6 plus 3, we get 9 omega total resistance of this. Next, we have to find the equivalent resistance for R3 and R4 also. So here R3 and R4 are also connected in series. So their equivalent resistance, let R double dash is equals to R3 plus R4. R3 is 12. R4 is 3, then we get total 15 omega resistance. Battery connected to the resistance R dash, which is equivalent resistance of R1 and R2. Similarly, there is another resistance R double dash, which is the equivalent for R3 and R4. It is here. Current is from positive terminal of a cell or battery to the negative terminal. Now, as we know, R dash and R double dash are connected in parallel. So the current is divided in parallel circuit, that is I dash across R dash and I double dash current across R double dash. And the current through 6 omega resistor. And we know that 6 omega resistor is connected with 3 omega resistor, that is 9 omega overall. So we have to find the I dash value. For first part, I dash equal V by R dash. Value of V is 4 and value of R dash is 9. That is 0.44 ampere current. Next, in part B, we have to find the potential difference across 12 omega resistor. So here 12 omega resistor is connected with 3 omega. that is equivalent to 15 omega. So first we have to find the I double dash value, and I double dash equal V by R double dash. Value of V is 4 and R double dash is 15 on 0.26 एम्पियर करंट. किस तरह से हमने क्वेश्चन को सॉल्व किया है. यहाँ पर R1 और R2 दिए थे 6 and 3 which are connected in series. First we find their equivalent resistance, that is 9 omega. Second, R3 and R4 also connected in series, that is 12 and 3. We find their equivalent resistance 15 omega. Now in part first we have to calculate the current across 6 omega resistor, and 6 omega resistor is connected in series with 3 and current is same in this series connection, that I dash current across their equivalent resistance 9 omega. Dash is calculated, which is equals to 0.44 ampere. Now we have to find the potential difference across 12 omega resistor. For this, first know the value of current. So I considered I double dash current across R double dash. R double dash is the equivalent resistance of R3 and R4. Then I find the value for I double dash, which is equals to 0.26 ampere. Now we have to find the potential across 12 omega resistor. So here potential difference across 12 omega resistor, let it is V3. Then V3 is equals to I double dash R3. Value of I double dash is 0.26 multiply R3 is 12. Then 3.2 volt potential across 12 omega resistor. Let us solve numerical number 20. Two resistors with resistance 5 omega and 10 omega respectively are to be connected to a battery of EMF 6 volt so as to obtain first part minimum current, second part maximum current, and have to find how will you connect the resistances in each case. Minimum current, we know that resistance of the circuit will be high, that is I inversely proportional to R. If resistance of the circuit increase, then the current will be decrease. So here we know that series circuit has a high resistance. For minimum current, we have to connect these two resistances in series, that is R1 5 omega and R2 10 omega, so that the current will decrease. Next, maximum current. For maximum current, we know that resistance of the circuit will be low. So here we have to connect these resistances in parallel. So we get our answer, that is series and parallel connection. Here, how will you connect the resistance in each case? So in first case, we connect R1, R2 in series, and in second case, for maximum current, we connect both the resistances in parallel. Because in series, resistance overall increases because both the resistances are connected in a single line. So the current of the circuit will be decreased. Here, resistance of the circuit is overall decrease, but the current increase. So here, in second part, calculate the strength of total current in the circuit in two cases. First, we find the current across series connection. We redraw the circuit, that is R1, R2, 5 omega, 10 omega connected to the source of power supply, shallow battery with a closed switch, and close the circuit. Here EMF of the battery is 6 volt. So now we have to find the value of current which is flowing from positive terminal of a battery to the negative terminal, that is I, we have to find. Now first of all we have to find the equivalent resistance of this series combination. We know that in series combination R1 plus R2. Then equivalent resistance is equals to 5 plus 10, that is 15 omega. Now value of V is given 6 volt and I equal to V by R. Value of V is 6 and value of R is 15. On cancel it by 3, we get 2 by 3, that is 0.6 7 ampere current flowing in this series combination. Minimum current series combination works for maximum current parallel combination works as resistance of series combination increases and resistance of parallel combination decreases. Drawing the parallel circuit to find the value of current. Here resistance R1, resistance R2, 5 ohms and 10 ohms are connected in parallel. Connect to a source of power supply, that is cell or battery, EMF 6 volt. Connect it to the close switch and then close the circuit. Here first of all we have to find the equivalent resistance, and direction of current is positive to the negative. So equivalent resistance of R1 and R2 for parallel combination is equals to 1 upon R1 plus 1 upon R2. Value of R1 is 5 and value of R2 is 10. On taking the LCM 10, we get 2 plus 1, that is 1 by R equivalent is equals to 3 by 10. On taking its reciprocal, we get 10 by 3, that is 3.33 omega resistance. First we draw the circuit diagram for this parallel combination and find the equivalent resistance. Now we have to find the value of I. 18 by 10, which is equals to 1.8 ampere current. Question number 21st. The circuit diagram given below shows the combination of three resistors R1, R2 and R3. Here R1 is 4 omega, R2 3 omega and R3 is 6 omega. Find total resistance of the circuit. Here R2 and R3 are connected in parallel combination, that is, so their equivalent resistance, let R dash is equals to 1 by R2 plus 1 by R3. Putting their value, we get 1 by 3 plus 1 by 6. On taking the LCM of 6, we get 2 plus 1, that is 3 by 6, which is equals to 1 by 2. Then taking the reciprocal of R dash and 1 by 2, we get their equivalent resistance equals to 2 omega. Now I redraw the circuit diagram here, that is R1, that is R dash equals to 2 omega, R1 is 4 omega, connected to a power supply, that is battery of 12 volt. Now here R1 and R dash are connected in series. So equivalent resistance of this circuit is equals to R1 plus R dash, that is R1 is 4 omega plus 2 omega. We get overall 6 omega equivalent resistance, that is part A. Equivalent resistance is equals to 6 omega. Current by Ohm's law, we know that I equal V by R, that is equivalent resistance, and V is given 12 volt. Equivalent resistance is 6 omega. Then the value of current is 2 ampere. Now in part C, we have to find the potential difference across R1 resistance. Here let potential difference across R1 is V1, across R dash is V dash. So we have to find the value for V1, and by Ohm's law, V1 is equals to I R1. Value of I is 2 and value of R1 is 4, that is 8 volt potential across R1 resistance. So here first we find the total resistance, which we get 6 omega, then total current by Ohm's law we get 2 ampere, and then potential difference across R1. Here both these resistances, equivalent of these two resistances and R1 are connected in series, and in series we know that potential drops takes place. So the potential across R1 is V1 and we have to find the V1 value, which we get 8 volt. Question number 22. In the circuit diagram given below, the current flowing across 5 ohm resistor is 1 ampere. Find the current flowing through other two resistors. Here it is 5 omega resistor, it is 4 omega, it is 10 omega resistor. Let it is R1, it is R2 and it is R3 connected to a source of power supply. Now the direction of current is from positive terminal to the negative terminal. Here R1, R2 and R3 are connected in parallel. So the current is divides, that is I1, I2 and I3. Now we have to find value for I2 and I3. So here first we have to find the value for V, which is not given. Then V equal I1 R1. I value is 1 ampere and R1 is 5 omega. So the value of V is 5 volt. Now we have to find the value for I2, that is V by R2. Value of V is 5 and R2 is 4. We get 1.25 ampere current. Next we have to find the value for I3, that is V by R3. Value of V is 5 and R3 is 10, that is 1 by 2, and on dividing it we get 0.5 amperes current. So these are the values of the current across R2 and R3 resistances.